This is problem 35 from chapter 15 of the textbook Stats Modeling the World by the authors BVD. So what we have here is we want to travel from Boston. Let me see. We want to travel from Boston to Denver, but we have to stop at Chicago and then get on a different plane and fly to Denver. So maybe some of you have done that. So the thing is that when you get on a different airplane, you kind of have to take some route that the people take, but your luggage has to take another route, and so sometimes your luggage doesn't make it, and so then you end up at Denver without your luggage. And then if there's lots of flights, then your luggage will just come on the next flight. So sometimes it's a minor inconvenience, but that's the situation that we're looking at. So they give us some probabilities. So let's see, the probability that you actually connect and leave on time from Chicago, leaves on time, is so let's say on time, that would be 15%. And then so from that we could say not on time would be the complement, so that would be 85%. Okay, so that's information given us. And then let's see, if it's on time, then the probability of your luggage making the connection is probability of making it, let's say, connect. The luggage is connect if you're on time. So it's kind of like a conditional probability. That's 95%. So 95% of the time the luggage makes it to the plane if you're on time. But the probability of the luggage connecting, given you're not on time, is 65. Okay, so that's the information that we've been given. So the first question they're asking us is that are the first flight leaving on time and the luggage making a connection independent? So the answer there would be no, they're not independent. They're not independent. Let's see. You could say the probability that the luggage makes the connection depends on whether or not they've made the flight is on time. Okay, so that you can almost see from right here that it depends on if the plane is on time or not. Okay, so you can write a sentence like that. I'm going to skip that for now. That's not the bulk of this problem, and I don't want to eat up too much time on that. So here they want to know what's the probability that her luggage arrives on time. So this is a little trickier than it first might seem. Let's model this, and I've done these problems before, so what I'm going to do is I'm going to say, well, let's say that the plane is on time or it's not on time. So first I'm modeling the plane itself. So if it's on time, as we were shown up here, that's 0.15. Okay, and if it's not on time, that's 0.85. Okay, now if it's on time, then let's say the luggage is the connection and then it says see, connects. So it's on time. We make the connection. That's 0.95. But the luggage is not connected. That's going to be 0. And I can figure that out because this has got to add up to 1, so it's 0.05. Okay, so by drawing the tree, some of these other numbers pop out that maybe I wouldn't see just using the notation. So down here, connect. So when it's not on time, it's 65. So 0.65. And then what's left? Well, 0.35, right? So not connected. Okay, so here you can see that this is 0.15 times 0.95, and this is 0.15 times 0.05, and this would be 0.85 times 0.65, and finally 0.85 times 0.35. Now these should all add up to 1. So you can always check to make sure that you've modeled the situation by multiplying these and adding them up. Just remember that parentheses are multiplication, but then these are like ORs. Either this is going to happen, right? You're going to be on time and the luggage is going to connect, or you're going to be on time and the luggage is not going to connect, or you're going to not be on time but the luggage is going to connect, or you're going to not be on time and the luggage is not going to connect. And remember, ORs are addition. Okay, so now, what was the problem they wanted us to answer? What's the probability that her luggage arrives on time to Denver? Well, on time to Denver would be this branch right here. Okay, so we would need that probability. But she could also be not on time and it still connects, so it would be that probability. So we would have to add the two. Okay, so the probability that the luggage is on time is equal to the probability of, if we were going to write this out, on time and connect plus the probability of not on time and connect. And we've really already done the work, so I can see this one, 0.85 times 0.65, and what was this? 0.15 times 0.95. Okay, right? This one and this one. Okay, so that ends up equaling 0.695 or 69.5% of the time. So this one, it might be worth writing a sentence that the luggage is expected to be on time 69.5% of the time. Something like that. Okay, I hope that helps. Now here's just one thing I wanted to point out. Sometimes when you start using trees, it's not clear which event to model first. So let's say you decided to model that you connected and didn't connect. What happens usually is when you try to make that tree, it gets confusing and it doesn't work. So in that case, flip it around. Model the other event and see if that works better. Usually that helps. Okay, good luck.